Hello and welcome to this lesson today. And today we're going to look at the past examination paper for ECZ, that is the Examination Council of Zambia. And we are going to answer questions from paper 1. And we want to practice how to answer these questions. It's very obvious up to now that probably we have a few weeks before the exam, or maybe a few days for some of you, some of us a few months or so. So it's very good for us to practice examination questions from the exam and past papers. So I usually encourage my students that once you have a bit of knowledge on a particular subject, go ahead and solve question papers, past question papers. So this particular one that we're going to look at is from the November 14th 2019, and basically this is you are given 2 hours, and the instructions are that of course you write your details, and electronic calculators and mathematical tablets should not be used in this paper. Cell phone not allowed. Okay, so we are not allowed to use any electronic calculators, so we just have to calculate everything from it's just you answer booklet, your pen, and your mathematical set. If you do have one, you should carry one. So let's go ahead without wasting much time to answer these questions. So question 1 said, evaluate -1 to the power 0 multiplied by 2 to the power 3. Okay, so these we're talking about indices here. So from indices we know that anything to the power to the power 0 should be a 1 multiplied by 2 to the power 3. And so this is 1 times 2 to the power 3 basically means 2 times 2, which is 4 times 2 again, which is 8. Okay, so 8 times 1, which gives us 8. Okay, pretty much straightforward for 2 marks. Okay, so we have 8 here. So I'm going to try to go as fast as I can in some questions because we have got limited time, and we'll try to cover as much as possible in this time. Question 2. So the equation x minus 1 2x plus 5. So when you have these equations, so what basically means is that when you have two numbers, this one and this one, when you multiply them together, they give you a 0, which means either this x minus 1 is equal to 0, or 2x minus 5, is it minus or plus 5 is equal to 0. So which just simply means, x here is equal to positive 1, or 2x here, 2x is equal to 5 will go on the other side, becomes negative 5, divide by 2, divide that side by 2, and x is equal to negative 5 over 2. If you want, you can put in mixed fraction as negative 2 and a half. So x is might be equal to 1 or negative 2 and a half. So these are the answers. Okay, so we're going to skip to the next one. Simplify 4x squared plus 2y squared minus x minus 6x squared plus 2xy. Simplify. Okay, so when it comes to algebra, I think you have to look at the first of all, the common terms. Do we have the common terms here which we can put together, and then try to see if maybe at the end we get factorize? Okay, so I can see we have a 4x squared here, we have x squared here, and 6x squared. So these are common, so we can put them together. So we can start with 4x squared minus 6x squared, and then y squared. We have another y squared, I don't think so, but I can see we have an xy here and we have an xy there. So I'll begin with the positive 1, so we'll just say positive 2 xy minus xy, and then what do I remain with? I've gotten rid of this one, handled this one, and that one, so I just don't have the 2y, so I'll put it at the end here, plus 2y squared. Okay, then see if I can work on this. So 4x squared minus 6x squared, that gives me negative not negative 4, negative 2 x squared, and 2xy minus xy, which just gives me a positive xy. Okay, that's a positive there, and then I remain with the 2y squared. So is there anything else we can do here? Factorization. Well, I think we can just leave it here. Can leave it here. Maybe we can factorize by grouping, but I think this is how far we can go. So we will end here, negative 2x squared plus xy plus 2y squared. This is the simplified version. I think there's no need to factorize here. If you can do that, but I honestly think we should just end there. Okay, so given that 17 plus m plus 27 plus are consecutive terms of an arithmetic progression, okay, find the arithmetic mean m. Alright, so when you mention the arithmetic mean, this is just the average of two numbers. Okay, so if these are consecutive terms, 17 plus m plus 27, the arithmetic mean m is equal to, so arithmetic mean is equal to 27. So if we have consecutive terms in, so if we have the consecutive terms a, b, then we also have c, then b is the arithmetic mean of this of a and b, and how you find of a and c. So and how you find the arithmetic mean b is by adding a plus c, then you divide that by 2, so that will give you b. So here the arithmetic mean m is equal to 17 plus 27, divide that by 2. Okay, so m is equal to what is 17 plus 27? 17 plus 27, that gives us, which gives us 34, right? 17 plus 7, that is 34, 34, 44, 44, so 44, so we have 44, divide that by 2, and we've got 22 for m, so m is equal to 22. B, for the sequence 11, 13, 15, find the formula for the nth term. Okay, let's find the formula for the nth term. So let's get rid of this part here so we can have space. Alright, so we have for an arithmetic progression, we look at the general formula, so which is this: a plus n minus 1 by the common difference. That is the first term plus the nth term minus 1, multiply that by the common difference. Okay, I don't know, I shouldn't be explaining most of these things, should just be solving, I think, or I should be explaining because I'm trying to race against time here. Okay, so the nth term for the formula for the nth term will mean that we need a, which is the first term of the progression, so that is 11, and we need the common difference, which is d, and the common difference we find that by subtracting when subtract the preceding term minus the preceding term. In short, we are going to subtract term 1 from term 2. Okay, the second term minus the first term, or the third term minus the second term. So the idea is just subtract the preceding term, the preceding term minus the preceding term. I think that should be it. So here we can subtract 13 minus 11, which gives us 2. So our D is equal to 2. And what else do we need? So I think that's all. So we say for the nth term, so this T with an N means nth term. The nth term, T for the term, and that's the nth term, is equals to 11 plus N, the nth term, minus 1, multiply that by D, common difference, which is 2. So if we would fancy expanding this one, we would say 2n, 2 times n, minus 2. And then this will be 11 minus 2, that will give us 9, plus looks like a T. Okay, so plus 2n. So the nth term is equals to 9 plus 2n, and then you have to indicate that this is the nth term. Okay, so that is how we find the nth term. Okay, so we can go to matrices. 8. The transpose of a matrix is negative 1, 4, 5. Find the matrix A. Alright, so the transpose of a matrix is the matrix where the rows of that matrix, of the given matrix, change into the columns of the given matrix. So if I give you a matrix A, then I tell you to give me the matrix of the transpose of the matrix A, what I mean is give me another matrix A where the rows of A become columns. So you have to change the rows. The rows of A will change into columns. So when we talk about a matrix, like the matrix A we have here, this is we have got rows and columns. The lines which run horizontally are rows, and those which run vertically are columns. So when you want to mention a transpose, that means you change the rows into columns. Those which run horizontally, you change them into vertical ones. So we can see in this matrix here, matrix A, it just has one row. Where am I putting? It just has one row here. Negative 1, 4, 5. So we have to change this row into a column. So the transpose of A as AT will change this one. Instead of being horizontal, it becomes vertical. In short, it becomes a column. So this is a transpose of A. So when you talk about transpose, what means you just change all the columns or the rows to become column. So rows becomes a column. So sometimes you might have a matrix with 2 rows, so you have to change those 2 rows into 2 columns. 3 rows, change those 3 rows into 3 columns. The B part says that if given that 1, 2, 3 matrix with 1, 2, 3, this is it's also known as a row matrix. A matrix is just one row, so row matrix. Multiply that by a column matrix, which is 1x5, and this should give you 24. Find the value of x. So if you have the matrix, we simply this and this is just matrix multiplication. And when you want to multiply matrices, what you do, we use the row by column method. We multiply row times the column, so which means the row of one matrix multiplied by the column of another matrix will give you one entry, a single number or single value, okay, into the new matrix. So if I multiply this row times this column, so how do we do that? So this first value of a row, you multiply it with the first value of the column, and which will give you 1, which will be 1 times 1, right? Then next, what do? We say plus. We add the second value of the row multiplied by the second value of the column, which is 2x, right? Okay, plus the third value of the row multiplied by the third value of the column, which is 3 times 5. I think we know that should give us 15. That is 15. And then these should give us what? 24. So we say we have got 1 plus 2x plus 15, sorry, should give us 24. And we know that 2x is equal to 24. Now 15 plus 1, that is 16. So when 16 comes on the other side, this becomes minus 16, right? We subtract 16 from both sides, and we have 2x is equal to 24 minus 16. That should give us 8. And then we can divide both sides by 2, and our x will be 4, right? So x is equal to 4. So according to B, x is equal to 4. That is the value of that is the answer here. That is what we have. So the answer is here. The transpose, we found that A transpose to be the matrix -1, 4, 5, and then we found our x to be equal to 4. So 9, what do we have here? 8. We're jumping to